So, thank you all for spending the next 30 minutes with me. I'm going to talk about basically three things. A little bit of context, what is ING? How did we transform ING? And then somewhat more about the last Agile mile. Because in my mind, we're almost there. And what we have to tackle is how we deal with IT risk. And IT risk, how the supervisors treat IT risk, how our internal auditors treat IT risk, how our CISO department treats IT risk. That has been a long discussion, and I want to share some insights with you. But the bottom line is, at the end of the day, IT risk is a function of skills of the human beings who create code and bring that to production every day. So I want to have some time to focus on that too. So, about ING. We have 30 million customers within 40 countries, and we have more than 50,000 people, and around 10,000 of them are developers. This is a map, thanks to Mr. Wardley. I have to give him some credit, and by putting in some maps, these are the countries that ING is working in. We are like number 10 in size of the banks in Europe, and one of the things that's important for us is the Net Promoter Score, meaning how many of our customers really would recommend ING to their friends. And as you can see, in most of the countries, we're number 1, and that's a thing that we want to keep that way. And for us, in our conviction, our belief is that engineering and engineering skills and engineering culture is vital to keeping that number 1 place and even getting better and better. So, for that, the last 5 years, we have been transforming ING. We started in the Netherlands, and where we started was basically an organizational structure, and I hope you forgive me for simplifying it big time. We had some commercial colleagues, we had guys who did application development, and also guys who were responsible for running the applications. We did the same for infra development and ops, right? This was, in a nutshell, our organizational structure, and it also showed you the way of working. The plans, the minds were the commercial people, and the application developers got PIDs, and they so project initiation documents. This is where ING still had a beautiful integration of Prince2 as a program management methodology with rational unified process integrated in it. Basically leading to 60 documents mandatory that you had to fill in before you could take any code anywhere, right? So this was hampering speed big time, and some of the guys and girls in ING they led this little revolution, and they were Danny Wijnand and Evelijn van Leeuwen. And they told our CIO in the Netherlands way back then, hey guy, we want to do Scrum, and if you don't, we will leave the company. And to their surprise, Ron said, hey, let's do it, let's give it a chance. So basically that meant that we neglected all the mandatory documents that had to be created, and that this team was hugely energized to make a difference. My good friend Amira Rooney, who was still the head of channels way back then, against all rules and regulations, brought in some IMAX and other stuff that the teams needed, basically paying it with his own credit card. This is a little bit of the revolution that happened way back then. We appointed product owners on the business side. They started to collaborate with us and playing with us. And this all was great, and the whole Scrum thing, not DevOps, but Scrum thing, was spreading around like wildfire. We saw architects doing sprints, and it was beautiful to behold. And then we reorganized, basically, because all that Agile Scrum was great, but we put a lot of pressure on the application operations folks. So a big decision of the management team of ING was to put the operations guys and the development guys together in one team of maximum of 9 persons. So big debates way back then, do we need 3 ops and 6 dev, or 2 ops and 8 devs, right? How are we going to do this? And there was no best practice. We looked around in the market, there was none. So we just did it. And that was cool. We ended up with 180 DevOps teams for the Netherlands bank. A lot of unease in the beginning, people trying to shove big cabinets between the ops guys and the dev guys when they sat together. And we had to fix a couple of things because the dev guys and the ops guys still had different managers, so half a year later we fixed that. But there was the atmosphere of, hey, we're just going to change the organization in a way that everybody can take responsibility. And this also meant that the DevOps teams, these 180 teams, they were on call themselves, right? So if something goes wrong with a component in production or a piece of software in production, it's you, the team, that will be called. There will be nobody else. And that really helped for people to take responsibility, and there was this beginning of an engineering culture, right? We're going to fix our problems by being great engineers, learning a lot, becoming great engineers. However, all of this created new problems. It put a lot of pressure on the commercial side too. So we had this an example where a guy found some code that was creating problems for our customers. He could fix it in 15 minutes or an hour, but the whole decision-making process on the business side took 2 months, right? And this was where our commercial colleagues expressed a little bit of unease, right? They said, hey, wait a moment, you guys going faster than we are, right? And we were extremely proud because in the years before, we were always seen as the bottleneck, and now we're not seen as the bottleneck anymore. But we had to fix this problem, and then they did something amazing. They said, wow, well, you know what? We're going to take a whole layer of management, and they did, or 2 layers actually, and we're going to reorganize this Dutch bank in 13 tribes with over 400 squads, where we have business representatives, developers, and ops guys in one team. So by this time, we already had these 400 teams. And of course, this was amazing. There was much more balance in the teams. There were more women all of a sudden also, which was good. Which was really good. And the engineers starting discussing about the real business problems, starting learning about that, which was really good too, because that was much better than just getting a list of user stories that you had to turn into code, right? Now understanding with all the brains in the team together what the customer journey really was, that really helped. Anyways, this still created a problem. And the problem was that we were putting a lot of pressure on the infrastructure department, and we were trying to fix that. So we did a reorg there too, and we created something called private cloud. Basically, it's our first step to public cloud. And we were still left, however, with manual IT risk, right? So IT risk in a bank is a very important thing. I don't know, are there any people here who work in a bank or in an insurer? Right, this is a thing, eh? So by law, you need to have a first, second, and third line of defense. So the first line of defense are the risk people in your domain. The second line is an extra group of risk people outside of it. The third line is the corporate audit services that will also audit the work of the engineers. So there's already a lot of organizational structure around it, and there's a lot of pre-existing thinking around it, right? So how do you tackle that? And this was a very tough journey, and where we want to go this year basically is make sure that all of these risk issues are designed away in our way of working. And I want to talk a little bit about that. Is that okay? Is this interesting? Yeah? So here's a different org structure. I would not have imagined 4 years ago that I would be talking about org structures this much, but here's the problem again, right? Where we had different silos in the past between dev and ops. Now we have different ones for security, the CISO department, IT risk management, the application developers and operations guys that are happily in one team and that use continuous delivery as a service, basically all the tools and pipelines as a standard that they can use. Then there's infrastructure, and there's corporate audit services, right? And all these peoples have different views upon reality, right? And this is just a human thing. We all look at reality through a little straw, and we think that what we see is the reality of everything, but that's not true. So this is where we needed to come together and jointly solve this problem of all the work that we still have in IT risk. Sounds familiar? So what we did is basically this. That is a policy that is recognized by our external supervisors. It's based on an open source framework like COBIT or something like that. And it's important because then the first step is something that external supervisors also recognize, right? But then we did something different, and I'm going to talk about that a little bit more. We defined a number of principles that were very important to us. And then based on these principles and the policy, we created a new control framework and then pipelines that adhere to this control framework. Earlier this morning, you could have seen a talk by a colleague from Xavier. He was talking about being compliant in your pipelines. This is what I'm going to talk about is the broader version of it. So it's not only roles and responsibilities, it's not only auditability, it's making sure that you have a complete control framework that covers your way of working and that takes away all manual work for the developers. So this is the first principle, really. So we want to be fast. So, and if you want to be fast, you have no time to fill in a lot of forms. So speed for us is a principle. And basically what it means is we no longer want to fill in a lot of forms just to satisfy the auditors. Yeah? We want to have something different, basically being able to go to production really, really fast and not create a lot of evidence only for the sake of being auditable. Then another principle that we stole from a guy called Jeff Susna. He wrote a wonderful book about designing delivery, is outcomes over impositions. And you see, here's a bit of the problem. In the IT risk people really want us to be great at IT risk, right? And IT risk is basically availability, security, integrity, and privacy of customer data. So they want us to be really good at it, and they worry about this all day. And their way to help us is basically creating little process steps so they can enforce upon all the teams to think in terms of IT risk. Reality, however, is that this is felt as an imposition. It is imposed upon the developers, and you find somebody who is, well, maybe not an adequate programmer, but still in your team, and you get him or her to do all this stuff, right? And that's a waste for everybody, because at the end of the day, availability, security, integrity, and privacy, they are design things, right? They should be the concern of the whole team, not just of one person. And they should not be reflected by documents, but by living it, and by constantly iterating on it, making it better. So outcomes over impositions, basically, what is the outcome that we want to have here? And the outcome is not a filled-in form, but the outcome is meeting our availability objectives or meeting our security objectives. And by defining those objectives as outcomes that we want to reach, we can give the team way better problems to solve. So why so much time on this principle? Because for many people, this is a big shift in thinking, right? It's a step away from good old workflow thinking or process modeling thinking. You can go to an outcome directly by designing for it. And that's important because for a bank like ING, all the software that we have and all the people that are changing that software on a daily basis, this is a really, really complex system. We now have over 750 teams worldwide with the ability to change the runtime almost every day, per day, or even more often that they want to. So how can you make sure that this happens with high availability, security, etc.? That's a big design problem. And you cannot solve it by saying, okay, each and every one has to adhere to little process steps and filling in forms. That doesn't solve it. You have to look at the whole system. And then address the systemic availability and security issues in one go. So this complex system thinking and the feedback loops, which are the foundation for making sure that complex systems get to the level that you want them in terms of availability, security, or whatever, that is what you have to design. So in this whole discussion, we just talked about outcomes and impositions a lot. And I would just want to give you a small sample of this discussion, right? So if you talk about availability for a bank, there are three lenses that we found that you can have a look at availability. So one is the system must not go down, which is great. And you can do a number of things. You can do better testing. You can do less changes. You can do you can prioritize problems so they don't become an incident, etc. Right? So that's all great, but this whole thinking is rooted in basically the past, where we had a system that supported a business process, and this business process was up or down, right? But currently we have a ton of small little services, and they all can go up or down, and they are being changed also all of the time. So this is quite hard to achieve. Then the next thing is the mean time to repair, making sure that you are better in repairing stuff. And of course, that means better monitoring, better alerting, and these are all great measures. And a lot of effort has been spent in my beautiful bank to increase that. So all the teams had these big, expensive monitors with other TV screens, with constantly a view upon how their systems were behaving. We got better at alerting, etc. And still, this did not fundamentally change our uptime. So if you look at what the likes of Google or Netflix are doing, they are looking at this differently. So this is the third lens, right? They are looking at how can we minimize the impact on our customers. And then you get different measures. So you get measures like, hey, global releases to production. For example, your first release of a change is only visible or will be consumed by only 1% of your customers. And then you can automatically switch back to the prior version. Now that means that you can go from hours to seconds in terms of customer impact, which is a big impact in terms of availability, right? And having these discussions about, hey, how are we really going to achieve better availability as opposed to process adherence, that is the difference between outcomes over impositions. Make sense? Yeah? So I like to talk about this guy a little bit. He's a young guy. He's called Max Verstappen. He drives a very expensive racing car, and he's very talented, and he's great. And where he is really great at is finding control where the other drivers don't find it yet. So for this guy, speed and control are almost the same thing. You cannot go any faster if you don't have control. So, and then the question becomes, right, for bigger companies like ING, if you go down to this, if you go to this workforce that is organized in hundreds of teams that have the autonomy to change the bank at will, without going through processes, because there's no human mind that still can get the impact of a small little change on the rest. How can you really achieve that speed? What kind of control is it there that you really need? So this shift in thinking is very important for us. And I know one thing. You will not see Max Verstappen in the corner trying to overtake Hakkinen and filling in a form, right? That's not how it works. That will never work. So this is also what we don't want for our engineers. Our engineers are going to make the difference, and how can we help them to get to that level of control? And therefore, we have to talk a little bit about the shift in technology. And I could not resist. It has nothing to do with it, but I could not resist talking about this a little bit. To the left, you see a steering wheel from the 1990s, and it's innovative in the sense that you could take the steering wheel out, so you need less room for the driver to get in. That was already innovative. And I really loved the little green button, which says radio, and the little red button is even more great. It says boost, right? So if you press it, you go really fast. Now, Now, if you look at the level of control that is in the hands, actually, of the driver, of, in our case, the software engineer, it has shifted big time. So this is the kind of shift that is also happening in big organizations. I think, like ING, we need to empower the software engineers a lot more while designing pipelines that allow them to be fully in control. So how do you do that? How do you do that? And a little bit of that shift is we don't talk about DevOps any longer or BizDevSec RiskOps. It will never catch you. Somebody needs to, Sebastian, get a better term for it. So I'm charging you with finding a better term for this. But the whole idea is we can only do this together, right, and get this thing in the hands of the engineers. This also means that to be really in control, we have another principle. We call it shift left. So shift left basically means making sure that all human activity is to the left of quality assurance. It means very concretely, nobody is going to patch running systems in production without going through QA together with the apps on it, right? So this is a big shift, the shift left, and we really want to take it a little bit further because we suspect that we're still creating a lot of code that doesn't solve a real customer problem. So if we take a little bit more time to go slow in the design phase and then go fast in execution, this is where we really want to be. So really start deploying design thinking for all of the teams. And then to the right, of course, we have the little robots that are uniquely suitable for making sure that we're in control, making sure that all the audit results are there. If an auditor comes, we can just show them, here's the audit results, have a ball. So this is what we want to do. And that means that we want to go to immutable servers. This is not new. It's already been talked about for at least 5 or 6 years in the market. We're now at the place where we can actually do that. And we now have designed and brought to production our first also data stores as an immutable server. So that is really cool. This is a lot of innovation that is going on very, very much below the visibility line. So, and that means that we differentiate between kettle and pets. So kettle, is everybody familiar with this term? Some shaking. Who's not familiar with it? Okay, still some. So the difference is a pet is like a server that I have in production. If it gets sick, we take it to the doctor, we treat it well, we manually get access to it and fix it. And after a while, nobody knows anymore what has been fixed and not, etc. Right? So these are pets. We take care of them. Cattle are treated differently. We breed them, and when one gets sick, we shoot it, and we get another one. Yeah. Now, of course, remember it's just software pets, the kettle that we're talking about. So kettle and pets, these are principles for us to build a new control framework on it, right? And this also means that we treat all our infrastructure as code. We don't want to be in a situation where we don't know how firewalls are configured or basically flush everything with the exact settings that we have defined on the version control. This is very important, or go back to a prior version. That kind of control, this kind of control, is how engineers are in control. It's not by processes, but by version control, right? So, and this means that we had to do a lot of stuff that was not really in our comfort zone. We had to talk about policies. We had to talk about control objectives and controls, and we had to make sure that they were traceable for all the auditors, and we just went through it because there was no other way. We thought that we can fix this last big problem for becoming agile. And that means that we now created a world where we have a lot of little robots that protect the runtime of the bank. They are in control basically from everything to the right of QA. And we have pipelines that are consumed by humans. And these pipelines are what we used to call continuous delivery or continuous deployment. But they leverage these little robots, and the robots protect the bank and protect your data. So, and then we come to the hardest problem, right? The hardest problem is not the technology. The technology is easy. The hardest problem, I'm just giving a wink to My minutes girl. Explain that later. So here's the biggest problem. When talking also, discussing with the risk people, how do we really make the bank better in terms of availability, security, etc.? How come that if we're solving systemic availability and systemic security problems for the complete landscape, how come that we don't see it popping up as more green or whatever boxes in your operational control dashboards, right? What is not aligning here, right? Should we stop what we are doing? No, you have to continue. Okay, then perhaps something in our thinking, in our existing way of trying to control the bank is not right. And something amazing has been happening because my good friends, the risk people, say more and more, okay, Henk, this is a really good team that you have here. We let them off the hook with all the processes, right? But they've been tying it more and more to the quality level of the teams and the way that the teams have really understood how to design for high availability, security, etc. So that means that more than we try to acknowledge, it's the quality of the engineers that is the problem. And we will not get any better engineers if we still treat them in a rational, unified process kind of version of the reality as people with different roles and responsibilities that work together in a step-by-step process. The biggest difference is when people with different skills come together to solve a real problem. And the most amazing thing to behold is that people actually learn from each other, right? So after a while, somebody who was a designer and coder and tester also takes care of deployment because he learned it. And that is the kind of thing that we really need because every handover from one person to another is very expensive and we want to get to speed. This is why ING also took the responsibility, the engineers took the responsibility really for the HR framework of the bank. And that is something that almost never happens. So we designed a vision on how to do HR better and to recognize the learning that needs to be done by engineers and to build it into the DNA of the bank. So this is a little bit where we are. The last Agile mile, we're now standardizing a lot of the tools for people, so from Agile product management, so this is really no longer banking products that we manage, but software products. How we create software, how we test software, and how we operate software, and bring it as a standard to most of the teams. So this is where we are. And I want to finalize this little talk with this, right? It is the skills. It is the skills of the people that you work with. And learning is not compulsory, but survival is neither. So, thank you very much.